Hi, I'm Matthias and I would like to show you the advantages of microdams in potato farming.
Welcome to my video lecture on the effects of microdam in potato cultivation. During our project we observed the effects of 4 different countermeasurements in potato cultivation on the surface runoff and the soil erosion happening on these countermeasurements. So the first thing, we had 3 fields in 3 years, and each year had 4 variants we tested and 3 repetitions of each variant. So the first one was the conventional variant, where you have the classical, typical ridges and furrows of the potato cultivation. And the second one is the one with microdams. So you'll see it later on another slide, how these microdams are made, but they are basically earthened hills in the furrows between the ridges and should stop surface runoff and therefore soil erosion. And in this picture you can already see the darker areas between the microdams where water infiltrated after an erosive event. The third variant we tested was a greening of the conventional method. So basically you have the typical ridges, but in the furrows between the ridges there is a greening cultivated. And then the fourth variant was a green microdam variant, where you had the microdam variant, but just with a greening on the microdams per se to further stabilize the microdams. So what we did is we installed sedimentary traps at the bottom of the field, and 3 furrows of each repetition and variant were merged in one merging area from where the water and sediment mixture was transported to the sediment trap. And within this sediment trap there was a tilting scale, and when the tilting scale tilted, about 3% of the mixture got transported in the blue casks and the other 97% were transported out of the field with the drainage pipes and through these drainages. The contents of the blue casks were emptied after each erosive event and then analyzed for the weight of sediment, and if possible, if enough sediment was around, it was further analyzed on the grain size distribution and nutrient composition. So this was our measurement on how much surface runoff happened on each variant and how much erosion happened on each variant. And then, since it's very important for farmers to not lose yield when applying a special countermeasurement to erosion, we also measured the potato yield of each variant and each repetition. For each measurement we took about 10 square meters of potato plants and weighed them and looked how each variant influences the potato yield. And then further we also looked at the soil moisture content of each variant with these green things you can see here. These are called flower power parrots and are used to measure incoming light, soil temperature, air temperature, but also the soil moisture content. And this is also one important factor for potato farming, or especially for the greenings, because a lot of farmers fear that the greening takes too much water out of the soil for the potatoes, and then the potato yield gets influenced negatively. So now let's talk about the microdams. Microdams are, as I already said, earthened up hills in the furrows. And the good things about the microdams is that they are made simultaneously to the cultivation of the potatoes and the forming of the ridges. So there is no timely cost or extra cost for the farmer. He doesn't have to go a second time on the field to earthen up these microdams. this happens while the cultivation of the potatoes also happens. And in this video, you can see how this is done. It's a simple technique where shovels dug into the soil, and after a given distance, in this case it was 0.9 meters, the shovels go back up and leave such a microdam behind. So let's see what the results show. And let's first start with surface runoff and with a picture of one erosive event happening in July of 2021. And you can see here, this is a first glimpse how good the countermeasurements work, because on the left side you can see the surface runoff, the content of the blue casks of the conventional method. What you have to say to the conventional method here is that not the whole content of the blue casks fitted in those containers, but a lot of water had to be poured out of the casks in order to fit all the sediment that was captured in the casks into these containers. And you can see when comparing the conventional to the green conventional method that there is already happening a reduction in surface runoff. And when looking at the microdam variants, you can see that there is a lot of reduction happening. There's way less surface runoff happening in the microdam variants because of the structure of the microdams. But this is just a glimpse. This is just one picture of a whole yearly observation of the surface runoff. So now let's have a look at the yearly observation. First, let's talk about the blue lines and bars. The blue line is the cumulative precipitation happening from May to September, so from cultivation start to the harvesting of the potatoes. And the blue bars show the daily precipitation amount of a day. And blue stars indicate erosive events happening on those days, or that this precipitation event happening on that day was an erosive event. So we can see that the surface runoff really was only triggered when a erosive event was happening. So that's a good thing. And then you can see with the red and the green lines, the surface runoff happening on each variant and each repetition. So the continuous red lines show the conventional method, the green continuous lines show the green conventional method, and the green and red dotted line show the microdam variant is the red dotted line, and the green dotted line is the green microdam variant. And you can see again that there's a big difference from the conventional method to the green conventional method, but a very, very big difference in terms of surface runoff from the conventional method to the microdam variants. The reduction from conventional to green conventional surface runoff is about 50%. The red line you can see here, which almost reached a surface runoff of 20 millimeters, is an outlier because it was placed in a lower part of the field where surface runoff from other fields got accumulated, and therefore way more surface runoff was happening there. So basically the reduction from conventional to green conventional surface runoff was about 50%, but if you look at the reduction from conventional surface runoff to microdam surface runoff, it's way, way, way less. It's about a 100% reduction, something like that. So a lot of reduction, way less surface runoff happening in the microdam variants. And this can also be seen in the images of the merging areas after an erosive event. And this event is the same event you saw the picture of the containers of. And if you look at the merging area of the conventional method, of the conventional variant, you can see that there's a lot of sediment got deposited A lot of fluvial structures from the surface runoff can also be seen in the deposited sediment, but there is a lot of sediment transported and deposited in the emerging areas. When looking at the greened conventional method, you can't clearly see a deposition of sediment in the emerging area, but rather in the furrows of the emerging area. And it seems that the greening stopped some of the, or most of the soil erosion and surface runoff, and then the sediment deposited in the furrows of the greened conventional method. And when looking at the microdam variants, you don't actually see any form of deposition or form of fluvial structures in the emerging areas. So there's basically no surface runoff happening there. And one thing that has to be noted is that when the microdams stay intact through the growing season, the surface runoff and the soil erosion we measured was happening in this emerging area. So we didn't actually measure any surface runoff or soil erosion happening uphill from the emerging area because none of the surface runoff and soil erosion got transported all the way down to our emerging area. It all stayed at the hill, at their position in the hill where it fell down. And you can see here again that after an erosive event, the water between the microdams gets infiltrated in the field and stays in the field. So now let's have a look at the soil erosion results. And we can see that if we had the conventional method or the conventional variant planted on the whole field, we would have had a sediment yield of 2.54 tons per hectare. And with the greening of the furrows alone, we reduced the soil erosion happening to about 83%. So that's already a lot. But with the implementation of microdams, we reduced the soil erosion and sediment yield happening to 99%. So there's not much more to say. That's really, really a lot of reduction happening. And we also saw the same results in 2020 and similar results in 2019. So our 3-year data also proves this image that microdams really, really are a great tool to reduce soil erosion. So now let's have a look at the soil erosion to surface runoff ratio. And as you can see here, all 3 counter measurements have a really good soil erosion to surface runoff ratio, with the green conventional and the microdam variants are basically on the same level in order to reduce soil erosion. But what has to be stated here is that the surface runoff happening in the green conventional variant is way higher than the one compared to the microdam variants, and therefore the soil erosion happening on this variant is also higher. So now let's have a look at the soil water content. And as I already stated, there are 2 things we would like to investigate regarding soil water content. The first one being whether microdams lead to a higher soil water content compared to the conventional method. And the second one being whether the greening of the furrow reduces the soil water content and therefore potato plants have less water available. So the first thing we want to look at is the microdam variants and whether they have higher soil water content. And you can see here on the image, also indicated by the letters A and B, that there's a statistically significant difference between the conventional and microdam variants. So yes, the microdam variants lead to a higher soil water content than the conventional methods. And the greening of the furrows does not reduce the soil water content in the furrows or in the dams, but it has to be stated that the parrots, the flower power parrots measuring the soil water content, were installed on the field after the greening was killed. So no active water uptake was happening from the greening, but the greening did not reduce the soil water content. So that's a good thing. And looking or comparing these results, the soil water content results, to the potato yield results, we can see that it does not look like the greening harms the potato yield, because the conventional method had the lowest median yield of all our countermeasurements. The green conventional method had the highest yield, and the microdam variance had a yield in the middle of both the green conventional and the conventional variant. So these results are not statistically significant, but as we've seen in other literature, they have measured the same thing. So they've also measured an increase in potato yield when applying microdams and a greening, but the differences were only seldomly statistically significant. So all in all, we can say that a greening reduces the surface runoff, but microdams reduce it way more. The greening reduces soil erosion, but microdams lead to way less soil erosion than a greening does. The soil water content stays approximately the same with the greening or with no greening, but the implementation of microdams increase the soil water content on the field. And the potato yield stays the same comparing the conventional method to a greening or to the microdam variance. There's no statistically significant difference when applying one of the countermeasurements, but data or other studies have shown that there's an increase, but not a statistically significant increase. So thank you for your attention and have a nice day.